And if I ask you, girls, connect these three resistance in series, okay, so that I can connect a battery there. So how can we connect them in series? What do you think? Three resistances are there itself now. I just want to connect them. So you need to connect all in a way, so that I can connect a battery. So just leave 2 points open to connect the battery and connect them all in series. What do you think? How can we do this one? I can just write down the names for, let's say it is 1, it is 2, it is 3, it is 4, let's suppose it is 5 and 6. Okay.
1 with the 3.
1 with the 3.
And a 3 with the 5.
Okay. Then
3 with the 5.
I'm asking you to connect in series. Don't copy what is in the slide. 4 and 5. Okay. 4 and 5 like this. Okay. Then 1 to 4, then 4 to 5. Okay. Yeah, you connect this way or this way, no problem. So now 2 with 3. Now see, now if we connect this way, what is the problem? Here we have open, this terminal is open and this terminal is open. Can we connect a battery here or not? Between 2 and 6. Between 2 and 6. Okay. So this is possible. So connection is, possible in different ways. It's not like only one way. We have multiple ways. Okay. It could be like that. I can connect from here to here. Okay. Provided we must have a single path to flow the current. This way. And now I can connect battery between this point and this point. So it is a series, any current is flowing this way. Getting? This is the way. So this is the connection. Okay. So it could be any different ways. Either if you are thinking this way, okay. As long as there is only one current is flowing, all is good. Is this series connection?
No, parallel.
If not series, it doesn't mean it is parallel. Keep in mind. What about this one? It is here. It is just connected, which is out of the circuit. It's open. So this is not the correct connection. Okay. So it could be like this one and this one possible. Okay. So that current can flow this way. Then it will come there. It will go there. Then it will come here. Then it will go there. So I can connect battery between these 2 points. This way. So it's just understanding at any current is flowing, same current is flowing, only one way is there. So this is series. If not like that, so what could be a parallel? In the parallel, what is the property of a parallel if I want to connect them in a parallel? All in parallel.
All the left and one line, all the right and one line.
There's one more than one path for current.
Cannot connect 2 components.
Okay, more than one path and must be connected to a common node.
Yes.
Must be connected to a common node. This is the point. So this is another node. This is another node. So this is the way. Yani, here I can connect a battery. If I connect a battery here this way, so current will start flowing here, and that current will split into 3 different paths basically. This is the way. So parallel connection. So series parallel, this is the just only difference. Okay, but here the thing is the concept will be same with what we learned in the previous chapters, like two nodes for the parallels, which is here. Okay, this is the node 1 and this is node 2. All right, so this is there, but series single path must be there. Okay, this is something. So series parallel concept. Okay, now so this could be a connection where your current is flowing this way, series connection, and for parallel, components that are connected in parallel will be connected across the same two nodes, which is like that, 1 and 2. Okay, all right. Now combination circuit. So what is a combination circuit? Most practical circuits have various combinations of series and parallel components. You can frequently simplify analysis by combining series and parallel components. Okay, so an important analysis method is to form an equivalent circuit. An equivalent circuit is one that has characteristics that are electrically the same as another circuit, but it is generally simpler. So one method which we will be learning now, which is called equivalent circuit method. Yani we can simplify a given complicated circuit into a simplified version, and both circuit will be having electrical same properties. Yani total current will be same, total power consumption will be same. Okay, but thus it will be more simpler, and equivalent circuit will be more simpler. Let's suppose we have given this circuit. Okay, these are the open terminals. Here we can connect the source. Okay, these two terminals. This is the circuit which is in the box, yellow box. So we can see here we have two resistances. So if I ask you, girls, find its equivalent, yani we need to simplify this one. So you need to find what is the relation between R1 and R2, how they are connected.
In series.
In series. So if they are connected in series, can we find the total resistance here by combining them?
Yes.
Which will be 1 plus 1, 2. So it could also be drawn this way, which is equivalent. Okay, and it is more simplified, yani only one resistance. Okay, the name could be R12 because it is mentioned there 1 and 2, and it is a combination of 2. So I can say simply R12 or R12. What is R12? It is basically the total for R1 and R, sum of these terms, R12. So this is more simplified version of this one. So it is called equivalent circuit. Okay, so let's have one more example. So there is no electrical measurements that can distinguish the boxes. Yani what they are trying to say, we don't have something like we can, it can distinguish the difference between these two components, circuits. Basically, if I connect here 12-volt battery, how much current will flow in the circuit? If I connect 12 volts battery here, how much current will flow if I connect 12 volt battery here?
12 volts.
12 volts.
In the first resistance or the total current?
6.
Will it be different?
It will be 6 milliamps.
6 milliamps. Okay, and if we connect 6 millivolts here, will it be same or different?
Can it be 6 amps?
Different.
Different. How it will be different?
Because it's not the same voltage.
I said here 12 volt I am connecting. I said the same 12 volt connect here.
You
Connect
said
here.
6 volts.
No, 12. I mean 12 volts you need to connect. I'm saying connect the same supply both the way. So same current will flow. So the point is, yani, though it's look very simple, but when we connect the same source here, it both will be having same current. And if I ask you to calculate the total power drop here and here, it is gonna be again same. So there is no electrical measurements that can distinguish the boxes. And what I explained, it is about this point which is mentioned here. So we cannot differentiate it because all are same. Only it is simpler compared to that one. It is having only one resistance, which is 2 kilo ohm. It is having 2 1. Okay, this is the only change. Otherwise, total current, total power consumption is gonna be same. See now here. So again, can we simplify these two? Okay, they are parallel. So
1.
So how much will be the total?
1.
If we combine them? Okay. So you will combine like 1 plus 1 is equal to 2.
It will be half. Half.
What is a half? Half real, half dollar?
Half.
500.
Half resistance.
Ohm.
Half ohm.
Kilo ohm.
Kilo.
Now 500 ohm or half kilo ohm. So this could be this way. So we can simplify this one, and in place of R12 we can have a single resistance whose value is 500 ohm, and which will also produce the same current if we connect the same sources here. So both are same. It's equivalent, yani more simplified version of this circuit basically. Let's see now this one. So how we will be simplifying this one?
This
What
is
is the
combination.
combination? Okay.
First, we add 2.7 to 1.
Okay.
Then we calculate the resistance in parallel.
In parallel. Ghadai, very quick. Just quickly add them all. It's not a summation, problem. I am not asking you, just add the numbers. Think about.
First in series, then in parallel.
2 kilo ohm.
Okay. So first in
R1
series.
and R2 in series. Okay. And then R12 with 3 is parallel.
Is parallel. So this is the way. This is the way you have to do this one. So you need to calculate first series. Then because you can see this branch R1 and R2 branch total is parallel with R3. So the way is that first we need to find this series. So first step is that we will find R12. Okay, R12 is what? R1 plus R2 because they are in series. After getting this one, now one step. So we have this one. Now this branch and this branch is in parallel. So I can apply here formula. Which one I can apply? Which formula? What's the name of the formula? I taught you when two resistors are in parallel. Simplified version. Do you remember that one?
Yes, we will multiply R1 and R3.
What's the name? What's the name? What's the name? Don't you have notebook to write these things? Huh? I tell you these things, so it's easy. What I ask you, you can quickly tell. This name is what? Product over sum. Product over sum formula. So it will give you what? RT is equal to R1, 2 multiplied by product over sum R1, 2 plus R3. That's it. Okay. So this is what? Product over sum rule. Product over sum rule, you can say simple. Okay. Because for the special case when we have two resistance in parallel. So after getting this one, we can have total resistance, which is 2.07 kilo ohm. So this is the equivalent resistance here. Okay, by the way, if you look these dots, they are still same. They are still same. There's no change. These dots are exactly the same. Either you look here, anywhere. So whatever you connect, you will connect between these two. So we just simplify the resistances this way. This is the way to simplify the circuit. Okay, let's see now. Formula you need to write, and what are the steps to do? AD is there. So what we need to simplify other than AD. Yani we need to simplify this one. Okay. So Ada is saying R2 and R3 in series. All right. Then.
And then R2, 3 with 4 with parallel.
Okay.
All series.
All series. Okay. Okay. Yeah, correct. This is the way. So if you understand the connections, it's so simple and you can quickly solve this one. All right. This is the way. For example, if I give you some values, for example, let's suppose I give you 10K, 10 ohm, 5 ohm, 5 ohm, and if I give you 5 ohm and 5 ohm, what is the answer?
$15.
15. Yes, good. Who said 4 in series? Manar? Who said 4 is in series? 4 is not in series. R2 and R3 is in series. These two are in series. So what you are trying to say? Are you asking?
I said why it's not in series.
You are saying R4 is in series. You are trying to say R4 is in series. Can you not see these points, how they are connected? How they are connected? If current is flowing from here, will it divide into two parts or not? One part, it will go here. Another part will go here. So, is it in series this way? If both branches are having different currents, upper branch have different current, lower branches different current. So how it could be in series? Series rule says same current has to be, but we don't have same current. So how did you calculate 15? I give you the value so simple, you know, because you know that when you are calculating and I gave you these values, so it is like you can calculate R2, 3, which is simply add them, because they are in series, R2 and R3. Both are 5, 5, 10, and then R4 is already 10. And you know that when these are in parallel, yani, what is that one? R2, 3.
10 multiplied by 10.
This one is that, okay? And we know that R over N, because similar value resistance are in parallel. So 10 over 2, yani 5. So I gave you these values so that you can quickly, you know, just add them. So after, you know, basically, if we redraw this one, so redraw will be something like that. First, I will simplify this one. So this will be something like that. First step will give me this. I will simplify R2, 3. Second step will be what? I will simplify this,
2, 3.
Yeah, so something like that. Now we can just write the value points A, this is D, and this point is given B, this point is given C, like that. So this is what R2, 3, 4, and this is already R1, and this is R4. So RT, yani total or equivalent, I can simply say, what is that? R1 plus R2, 3, 4 plus what next? R4. So 5 plus 5 plus 5 is 15 ohm. This way we can get this value. Clear to all?
Doctor,
Hmm.
R2 and 3, we added them because it's series.
Yes.
Then R4 should be parallel, right? With
Yes,
them.
R4. Yeah, it's in parallel. Yeah.
Yeah, okay.
Okay, because both are same here. Because 5 plus 5 it is 10. So yani when we calculate here, so what we are getting R2 3, we are getting 10, and R4 is already given 10. And you know the basic rule, when two resistance of same value are in parallel, correct, we can apply this formula R by N. Remember?
Yes.
But
Yeah.
it's shortcut. If you forget, you can apply that one also. What is that? Product over sum. So R2 3 multiply by R4, but it will take your extra time. If you have extra time, no problem. Use it. We will get the same answer, which is 5 all the ways. So it's up to you. So this is the way. Clear?
Yeah, okay. Thank you.
Okay, welcome. You can take a screenshot if you need. Okay. So move to next question now. With the value, we have solved this one. All right. Now let's see next one. So here they are asking total resistance. But which total? Between A to B. Yani we need A and B. Think in a way, if we want to connect a battery here, then yani A point is here, yani this terminal, and another terminal is this terminal. So I may connect a battery here, and I want the total resistance, yani I need to simplify whatever is here between A and B. No one can give the answer of this one. I am sure. You are 32. No one can give. Let's see. I am giving you time. Okay, the time is, how much is the time? 3:27. Giving you 2 minutes. Whatever number is there or not, I am asking you, just write the formula. R12 parallel with 3. What is that? Okay, you keep trying. I am reading. Numbers, leave it number. You just write the formula. Relation formula. See how confident I am. I said no one can reply out of 32 students. See my confidence. Half of any, we should bring a knife and cut half hair. How you are saying? Okay, keep up, like, yeah, keep writing, no problem. Shahad, new formula. What is that formula, Shahad? R1, R3 over R1. What is that? R1, RT. What is RT? what is RT? New formula is coming. Okay. It is 28. One more minute. So if I, just give up. Nothing. Khalas. No resistance. No, leave it. Whether what value could be anything. Value could be anything. Don't worry about the value. MashaAllah, you respect your teacher a lot. You don't want to break his confidence. Good. My confidence that no one can reply, and you are not reply. Though you know that I feel, but no one's want to tell. Huh? Okay. So time up. It's 3:30 now. 3 minutes past. Give up. Okay. Okay. Khalas, everyone give up. Huh? 32 students. Okay. Now see. Okay, what is it? Yeah, wrong. Everyone is wrong. I am reading the comments continuously. All are wrong. See my comment, huh? Mashallah, my confidence. Okay, now look. So it's same what I said earlier. Yeah, you look here. These one AD. So we just solve what is right side of AD. Previous question here. These two terminals are open. So we just simplify this one. Okay, so same is there here also. See these two terminals, and we simplify this one. Okay, so here is what these terminals are like. We can connect source here. Definitely this is open to connect the source. I told you. Okay, so now see what will happen here if I connect a source here. So for example, if I connect a source here, okay, so because of this source, what will happen? Current will flow. So let's suppose the current is here, which is that I total current IT. Now when it will reach here, will it split into two parts or not? Wait. Will it split or not? Okay. Yes. Okay, I muted all of your mics, so if anyone want to talk, you need to unmute. Okay, so let's say this is I1, and let's say this is I2. Okay. All right. Now here it could be A or B, no problem. Current direction can be anywhere. I am saying that current is flowing like this, so it is like that. Okay. Now see, so current 2 is traveling here, it reach here. So after reaching to here, yani here, where it will go? Left. Two ways. Ghazal said 2 ways. So here is the bucket. So all it will come and fill the bucket. You are violating the basic rule to flow the current. Don't you know? In order to flow the current, you must have a closed path. Will it go in the open air? Current can travel in the open air, like open, it's open. How current can go here? So basic, you are violating the basic rule, not possible. All the current which will reach here will turn here and will go to I3. So R2 and R3 is having same current. Yes or no? Okay. So this current, yani I2 will reach here, and I1 is already coming from here, I1. So it will again combine at this point and return back to the source as a total current IT. So What you conclude from here? R2 is in series with R3. Yani total, I can write it like that. R1 is in parallel with the branch which is R2 plus R3. Yani R2 and R3 is in series. So I can combine them. So this is what I am writing here. R2 plus R3. After combination, you can look here, this end and this end, yani two nodes are common. Forget the C. C is just a label, it's not thing. So these two, yani branch R1 and this complete branch, which is R2 plus R3. Yani I can say R2 comma 3 is in parallel. I'm just writing the sign for the parallel with R1. That is basically the RT. So is it clear? Clear or not clear to all of you? Right? So this is the way to understand the point. Yani series will be having same current. If same current is flowing there, they are in series. For the parallel, you know the rule. Must have common node. Must have common node. So this is a common node. After simplification of R2 and R3, it is in parallel with R1, which is, I can write something like that. This is not an actual formula because I just use a symbol here to explain you how it is basically connected. Now we can apply the values and we can solve this one. Clear? All right. If it is clear, now tell me, how much is RBC? Yani resistance between B and C. Jana, it is already mentioned. B, you need to find the resistance between A and B. Understand? A and B. So where will you connect the battery? Can you connect the battery between B, C and B? Understand the point? It's mentioned there. I highlighted the things in the beginning that A to B. That's why, okay? Now, what is resistance between RBC? RBC? Any point B and C, total resistance between point B and C. R2 is in parallel with R1 plus R3. Yes, you are right. So you got the point. R1 plus R3, because they will be in series in this case. And this will be in parallel with R2. Are you clear to all, guys? All of you? Because this time B and C, okay? This time B and C. So current will be coming either from here or here, no problem. But it will split either here or if you want to say here. So it will split into two parts. If you look this way, two parts. So whatever current will come here, same will go there. So they are in series. And this complete branch R1, 3 is in parallel with R2. This is something. Similarly, you can also find R, A, C, any resistance between A and C. So if you go for A and C, what will be the total resistance? How can we calculate? Relation. So this formula is telling the relation actually. It's not telling you the value. So relation. It will be R1 plus R2, which is in parallel with R3. This is the relation. And you know that how to calculate parallel and all these things. So whatever value is given, you can calculate simply. Any doubt? or clear to all? All right. So this is something, you know. So understanding is main thing, yani how the current is coming and how it is splitting. So same current, yani simple series, different current, yani parallel. Okay. Still confusing? What is confusing? Later on, don't ask me any question about this figure. You can ask me right now. What is confusing? Tell me. RCB. Why it is confusing? RCB. If you connect a battery in between these two terminals, what is the confusion here now? Tell me. What is the confusion? Silence. Silence is the confusion. Batul? You are confusing me, not saying anything. Are you listening? Yes, girls.
Can hear you, doctor.
Okay. So Batul, what happened? What is this RBC? RBC same thing, na? RBC any resistance between B and C. I said like that. So what is the problem here? If you say this is the current, so current will come here. After reaching here, current will split into two parts again, as I mentioned earlier. So this is the way. This current will flow here. Okay. After here, all current will go there. Yani R1 and R2 is having same current. So they are in series. Yani R1 plus R2. Sorry, R1 plus R3. Now this branch. Okay, I can simplify this circuit even after this point. Yani this one I already simplified, and this is what? R1 3. This is the same point. Which point? B and C. So now this is something. So can't you see this is R13 and R2? They are in parallel. So what I said just, I said R1 plus R2. Then I put a symbol that is showing parallel with R2. This is something. This is R total in this case. Okay. See, if you are silent, it is, I don't know, you have mic. You can talk. If you are silent, it is, I don't know. Yeah, it's same formula. What is the formula? I'm just applying parallel and series formula. But you need to understand which one is in series, which was in parallel. Then you will, just simply add them. Let's see. You may the point will clear later on with other examples. Let's see this one. So I need a total resistance between A and B. Between A and B. Yes. So what is the relation here between A and B? All parallels. Okay. Okay, all are parallel, so you have the formula. Reciprocals of the sum of the reciprocals, which you can apply simply. So all are in parallel. Okay, all are agree about this point except 3. So 3 is not parallel. Zara is thinking is not parallel. 4 is also not parallel. 3 and 4 are not parallel. R4 and R3 are in series. Okay, they are in series. Okay, there are 3 and 4 series, other parallel or parallel. Okay. What is the difference between this one and this one?
First, R2 and 3 and 4 are in parallel. Then R1 is in parallel with R2 and 3 and 4.
What is the difference between this diagram and this diagram which I drawn?
The second diagram is all in parallel.
So not here.
Here also in parallel, but in a different way.
Parallel or not parallel? This is the point. Different way, any if parallel, if any parallel. If not parallel, not in parallel. Simple.
No, they're both parallel.
Fatima, this formula is 100%. What other will say if I use this thing? 100% wrong. This is not a formula, keep in mind. You cannot use anywhere. Neither I teach you, nor you can apply this one. Why? Yani, see, why means you have to go and open the series chapter and study yourself. Okay, Jana is replying, only you have 2 resistances. Yes, Jana, correct. This formula is applicable only when you have 2 resistance in parallel. Now you are applying for 4 resistances. So it is absolutely wrong. Okay, yes. No problem. Good. You make mistake. You will learn from your mistake. Don't worry. And don't be shy when you make the mistake, because things are in your mind, and until you not speak about it, you will not understand. You know, the things will be inside you. Inside it should come out. Then you will be understand. Okay, so both are same, dear. Not at all any difference. This is same point as this point, and it is same as this point, the same point. Even if I draw A here and B here, it is same. It is simple parallel circuit. I am not teaching you still, you know, combination. It's not a combination. What is the rule of the combination circuit? Sorry, parallel circuit. Do you remember the rule for parallel circuit? What is the rule?
1 over R1 plus 1 over R2, etc. all to the power -1.
This is called formula, dear. It is not called rule. I am asking you the rule, and mashallah, tomorrow you have quiz. And if you want to know the rule is here. Same two nodes. How many nodes you are having? So are they connected between A and B or not? One end of each resistance is connected to A. Another end of each resistance is connected to B. If yes, it is a completely purely parallel circuit. There should not be any confusion. So I think I should make a difficult quiz for tomorrow, so that everyone will study. Otherwise, you people are taking lightly. You need a challenging quiz. It means is that so that you can study very well. There is two ways to study. One willingly, happily. Another one forcefully. So first I am trying willingly, happily. You enjoy the lecture and you study. But if you not enjoy or study, I will make challenging questions. Then you will start crying, sending mail, teacher, and nothing will happen. I have nothing in my hand. What do you want? Which rule? Rule 1, rule 2? Challenging questions, Rule 1.
Rule 1.
Rule 1. Okay, how many of you like rule 2? Challenging question, so that you will study more by force. This is by force. And this is by choice. No one. Okay, Mariam said no rule. Just teach teacher and bye-bye. Or study well if you want. It's simple circuit. It's nothing here. I did not ask you anything. Now it's coming. See next. Now you can scratch your head. That is okay. But why are you scratching head for the simplest question? Okay. So read the question. What you need. So it is, we start now here solving the questions within numbers. So I need current through R4. What is current through R4, girls? Which current is R? Is this the one? I4? Okay, so I need I4 bus and I will give you 2 marks. So how you will approach for that if this question come for 2 marks? It's up to you. How you will be solving this one now. So now you need to apply KCL, KVL, Ohm's law, current divider, voltage divider. That's it. Anything you can apply. So Mariam, write it specific, don't write general formula. You have a specific circuit now and you need to find the I4. Okay, write the specific formula. Yes, everyone think about it. Voltage source is given to you 5 volts. Yani 5 volts is connected here. Let's see how you will be solving this question.
Maybe we should
يعني simple the circuit R3 and R4 maybe.
Okay. Okay. Okay.
And it will be one يعني one load.
Okay. It will be
يعني
one.
simple the circuit.
Simplify the circuit. Okay. Simplify the circuit. Yes, possible. Why not? Why are you adding R3 and R4? Now, adding means jama. Jama yani Arabic word, I don't know. Sum. So do you need to add them? Are they in parallel or are they in series?
Last year
Relation.
R3
They
and
are okay. R3 and R4?
Yes, the يعني the circuit R3 and
Okay.
R4.
Series or parallel? What do you think?
Doctor,
Yeah.
because the R3 and R4 are parallel series, are parallel, there is an equation for to find the current.
Okay.
It is I for the R total to the R4 and the current total. I don't have a current total.
Oh,
Right.
so this is the point, na? You don't have the current total. You need to find the currents also. Maybe you need to find the resistances also. Then you can approach. Mariam is calculating and she calculated I4 is equal to 8.9 milliampere. Okay. So first of all, tell me who was telling Fatima and all, I think. R3 and R4, are they in parallel or are they in series? Mariam, wrong.
Doctor, it's correct when we added R3 to R4, okay? After that, we will have two resistors in one load, R2 and R3 or 4, it will be series and we will edit it. And after that, R2 and R1, it will be parallel.
Okay, but it's okay. But so what do you think? Is R3 and R4 is in series or in parallel?
Parallel.
All circuit is parallel.
No.
But
Only I am asking you R3 and R4, how they are connected? Are they connected series or in parallel?
In parallel.
Doctor,
Yeah.
can you
Shahad, you said R3 and add R3 and R4. Add yani
No, it is parallel.
if it is parallel, so you need to find their combination. So
Yeah.
if they are in parallel, actually, you cannot add them. You have to apply parallel formula. That's why I am asking you how they are connected. Are they connected series or parallel? If series, you will add them R plus and R4. But if they are parallel, are you going to get it R3 plus R4 or you need to apply the formula product over sum rule? Understand? You need to apply product over sum rule. Product over sum rule. This is the way. So you need to find first there. What you said, it is okay. What you said, go this way. The approach is absolutely correct. Yani R3 and R4 must be combined as a parallel. They are in parallel because connected between B and C. So after getting parallel, you need to add R2 because R2 will be in series with that combination. Then the overall will be in parallel this way. So this way approach is absolutely correct. But the relation I was asking to you, they are in parallel. So this way we can go to for this the solution of this question. Okay, just a minute. Okay, have you solved it? Who is Fai? What is that one? 207.64. What is that one?
In parallel, R3 and 4.
R3 and R4. Okay, so just keep your answer ready. I will ask you just a moment. Okay. So first we try to understand the concept. So tell me the step to solve this question. Steps. What should I do? Okay. So step, you can just tell me any what you need to find first, then second, then third, then fourth. Can you just elaborate quickly?
Okay, we
Steps.
can find R3 and 4.
Okay, so can I say R2, 3?
Yeah.
Oh, sorry, 3, 4.
3, 4.
R3, okay, R3, 4
And
is
then
equal. Okay, it is basically what? R3 in parallel with R4. You are trying to say like this, correct?
yeah.
Okay. Second step.
R3, 4 with R2.
R2, 3, 4. Okay. Yani R3, 4 plus R2. Girls, are you getting?
Yeah.
Okay.
And
after,
then R2, 3, 4 parallel with the.
so it is R total. Correct or not?
Yeah.
Okay. So parallel
With
with
R.
2, 3, 4. Clear? Everyone agree?
Yes.
Okay. Now tell me the values. So first value here R34 207.64 207.64, and you don't want to write the units. I don't know, you hate the units or what happened with the units?
You know it.
No difference between dollar and real, all are same, huh? Is it like that? Okay. When you go America, then you have to spend dollar, and when you spend a dollar, you have to spend 4 times, you know, there 4 real is equal to $1. Okay, how much? R23. Okay, 537.64 ohms. Okay, final R total RT 274.29 ohms. Okay, so we reach up to here. What next?
We find I total.
We need to find I total. Okay, IT. What formula I have to write here?
VS over R total.
R total. Okay, so VS how much? 5 over this one. Okay, so calculate the value and give me. I will write the number only. 5 over 274.29. Okay, so 0.018 ampere or milliampere. Okay, can you convert it into milliampere? That will be more good, I believe. So 18.2 milliamps. Okay, this is good rather than writing 0.018. This is the way to write it. 18.2 milliampere. All right. So we have done these things. All right. What next? After this, we reach to IT, but my question was, I need to find I4. All right. So this is what we did up to now. But still, I did not find I4. So how can I find I4? What next? What is RT over R4 is equal to IT? But see the formula which you write here. This, you look here, I4 is a part of a total current or it is a part of I2? Total current is dividing here or I2 is dividing here? So it is a part of I2. So the total current for at this node, yani node B, what is the current which is incoming? I2, and I2 is splitting into two parts. Understand? So I can apply current divider here surely, but the total current is I2, which is splitting here. So if I ask you formula to calculate the I4, the formula will be, what will be the formula? Formula will be, okay, so I can write it like, I'm writing here, I4 is equal to, do you remember the
Yes,
current divider formula?
I2 minus I3.
Okay, this is KCL, not the current divider. That is
R
Kirchhoff.
total.
Yeah, because we are writing here current divider formula, special case for two resistances. Why are you writing general? It's better if you write, because two resistance is there, na? So I can write it. So this is R3 over R3 plus R4 multiplied by I2. Okay, did you get this one? This is a special case when two resistors are in parallel, current divider formula. It's there in the slide itself. Clear? So, in order to calculate I4, do I know R3, R4, I2? I don't know I2. I have to find I2 first. Getting point? So, I have calculated the total current, girls, and total current is coming from here, which is IT, and this IT is dividing into two parts. One is I1, another one is I2. Understand or not?
Yes.
So
Yes, doctor.
yes, so now when you are solving for this one, if you draw the the simplified circuits here step by step, that will help you a lot to understand this concept. See, so first step, this is point B, by the way, this is R2 and that is R3, sorry, R3 and R3 4, yeah, this is R3 4 and this is R1. This is the first step, girls. Okay, then second step, you made something like this. This is R1, this is R2, 3, 4. Okay, now so these circuits will help you actually now to understand that formulas and all. So now, so let's take blue color. So now I am considering this picture now. So here is the total. See, all are equivalent. Keep in mind this same or not. We have discussed since beginning. They are equivalent, they are same. I can consider anyone which is helping me to understand the question. Okay, so this is what IT, here is I1, here is, let's suppose, I2. So what I need basically, what is my aim, what I want I1 or I want I2. I want I2. So can I write a specific formula to calculate the I2, girls? How can I find the I2 here?
We can say R1
Okay, R1
over R1 plus R2, 3, 4.
Okay,
Multiplied by I total.
multiply by IT. Okay, Shahad, correct. Yeah, girls, is it clear? Okay, is there any other way to calculate the I2 from this circuit itself?
Yes,
What is that?
it's RT.
RT?
Yes, RT over R2.
No,
R2.
which formula you are trying to use here? Tell me that one.
I'm trying to use the current divider formula.
So this is the one I already wrote here. This is the current divider
Divided
formula.
by the number.
Okay. Do you remember? Look here. Do you remember how much voltage I am applying here?
Yes.
How much? 5. All right. Okay. Can you identify this R1 and R2, 3, 4 is in parallel or not?
Yes, it is.
It is in parallel. So if it is in parallel, so they will be having same 5 voltage or not?
Yes.
Yes, same.
Okay. So you got my point?
So it's going to be V over R234.
Possible?
Yeah.
Okay. Apply, some students apply formula first one, some apply a second one and check the values. Are you getting same or not?
9.3.
9.3. Okay. You can use both of them. The value will be coming 9.3. Check it and tell me. So I2 is coming 9.3 milliampere. Second, okay.
Yes.
Apply the first one also and check. Values already calculated, values are already shown left side. Same. So understand different ways. Okay. Now come to this picture. So can we calculate I4 now? Bus calculate the I4 now. R3 over R2 plus R4, R3 plus R4 multiplied by I2. Now you can apply current divider here. See this one, okay? Yani this point. So I2 is incoming and it is splitting into I3 and I4. So I can say I4 is equal to this way. Go this way and tell me how much it's there.
$3.44.
Okay, so Zahra, without I2, can you apply this formula?
No.
So bus, this is the need. So the answer is 3.45 milliamps. Clear to all?
Yes.
Okay. So you go this way, that way, this way, this way, then you calculate the total current, then you do this one, that one, then you solve it after 20 minutes. I can solve it within 2 minutes. Not like I am a teacher, like the concept. Even you will say, yeah, teacher, it's so easy. You can solve it in 2 minutes. Think now first. I am giving you time again. I am confident some of you will tell that we can go this way. Okay. So consider again same circuit and tell me another approach to calculate the I4. Time is 4:13. 4:15, 2 minutes you have. Okay, break. Yeah, we can have break, no problem. Let's take a break if all are okay. So let's take a break for prayer, guys. Yeah, it will be good, and then we'll continue. So it is a 4:13. Inshallah, 4:25 we will start. So take a 10-minute break, and everyone can pray. And even those pray early, then you can solve this one. All right, good. So this is clear, huh? So do you think I ask you a question, any other way to get the I4 other than this calculating R4, R3, RT, I think a lot of things. Okay, I'm erasing all these things, okay? This is the picture was here. Yes, so no idea. Can we get I4?
Yes.
A different approach. What's that?
Wait, I'm writing.
Okay. You can tell also, no problem. What is the way? Others also try quickly. Otherwise, if not trying, then why should I wait? Okay. Mariam, what is that? Okay, you find R, then you find R2, 3, 4 by this one, 9.3, but then we can find the across R1, 3, R3. Okay. Okay, yeah, could be. This could be, yeah. Okay, all are back or not? Should
Yes.
I? Okay. Okay, look here now. Different approach. Only A plus students will be doing these type of things, you know. So inshallah, I will separate A plus A, B, B plus C, D. Everyone will separate later on. So see, look this one. So I am teaching to everyone, but if you remember, inshallah, you will be A plus. You can save your time. You can concept. You can have clear concept. All right, look here. So here already given Vs is 5 volt. Agree? Okay, so we earlier calculate R3 and 4. Okay, so I am just redrawing this one. This point. This is another point. This is point B, by the way. This is R2. This is R3, 4. This is R1. And here we have connected 5 volt. Okay. Is this a parallel circuit?
It's a combination circuit.
Combination circuit. All right. So this branch, let me take different color. R1 is parallel with this branch.
Yes.
Yes. So same voltage will be here. Same voltage will be here. True?
Yes, it's true.
Yes.
All right. So here to here we have same voltage, 5 volts. All right. R2 and R2 and R3, 4 is in series.
Yes.
R2 and R3, 4 in
Yes.
series. Correct. So and they are having 5 volts drop. When we have a series combination, you know that the voltage 5 volt will be divided among R2 and R3, 4. Do you agree?
Yes.
Yes, we agree.
Okay. Can I apply voltage divider here to get V R 3,4 yani voltage across resistance 3,4? Possible?
Yes.
Okay. What will be the formula? Can you tell me? Voltage divider formula. R.
We will, yeah, R34, R total. V,
R. Let's say R2 plus R34. Okay. This is something. And
V.
V or VS. Huh?
Yeah, V.
VS. All right. So just calculate this one quickly. So R34, you have already calculated. I believe how much this was? R34?
207.6.
207.64 over. Now add 207.64 plus 330, which is 330 plus 207.64 multiply by 5. Calculate all.
It'll be 1.93.
1.93 volts. Clear up to now?
Yes.
Okay. So what we get? What is this VR3? VR34. The voltage across R3,4, correct?
Yes.
Yes.
And what is R3,4? Is it a combination of R3 and 4? Parallel combination of this one? All right. When R3 and R4 is in parallel, so they will be having same voltage drop or not?
Yes, they were.
Allah, same.
So it means, can I say it is equal to V3? Is equal to V4?
Yes, we can.
Yes, we can.
Then can I say I4 is equal to V4 over R4? V4 is 5, sorry, how much it is? 1.93 over 560 ohm. Get the answer.
0.00334.
3.45 milliamperes.
3.45
Yeah. 3.45 milliampere.
milliamps. So is this the same current which you received earlier, or it is different?
No, it's the same.
Same. So how is it? How is this approach?
It's easier. It's nicer.
Easy.
Easy. So easy peasy approach comes with, once you know all the possibilities, you know, I am not teaching you what is shortcut, what is that one. I am teaching you general. Then I am teaching you this way, that way, whatever possible, whatever coming in my mind, I am trying all, and I am teaching you all. Understand? So short or long, it is basically depend upon what is striking in your mind at that moment when you are solving it. That moment is important, right? So maybe you go this way or that way. See, this is something you can solve it. It's so simple. No need to calculate R3, R2, 3, 4, then total current, then I2, then multiply. So many things. This is so simple. This way we can simplify this one. So this way you will save your time, you will save your energy, you can gain more marks. This is the way. So how many teachers you find in your life, mathematics and all this, they teach you different ways, possibilities, this way which I am teaching? Very few. More? Not many. Oh, not many. Yeah. Okay, few. Again, very few. Okay, I am trying my different all the ways. Now it is up to you. The ball is in your court. I am trying my level best. You know what I am teaching? Why I am teaching all these things? Because I don't like my student ask me teacher, why did you cut my 0.1 mark, 0.2 marks, 0.3 marks? Because I don't like you people ask for marks. You people must ask for the knowledge, for the way. If I am lacking somewhere, ask me again and again, no problem. But I am trying my level best now. You should try your level best and you should gain the marks rather than just depending on the teacher. Teacher, please 0.1, I want A+, I am a A+ student. I have many emails, but these emails doesn't affect my thinking. I am here to teach you to deliver my best. I am delivering. Now it's up to you how you are going to take it. Okay. All right, inshallah. Yeah, I believe every one of you will do. You have potential. That's why I'm trying. Otherwise, if I don't find that you people cannot, I will go simply, this is the way, girls. Is it clear? You will say, yes, teacher, I will go to next. I am spending half hour to this question only. Why? Because if my student get, a complete understanding of one question, you just pick any question, you can solve it. It is, I believe in quality rather than quantity. So quantity, like quickly and finish it. So you will say, yeah, teacher, yes, okay. But see, again, another major point is that, main point is that all the time it is not possible. I can give you half hour to one question. I just given, much maximum time to this question because it is one question. Once one question is clear, all will be easy. And I have to finish the course. If I will go with this pace, I don't think I can finish this course in 2021. One question, half hour. So, okay, next question, next half hour. So you need to understand that one. Okay. So you have tomorrow quiz. Study well so that, and have you seen here? I use all the rules which I taught you. Did I use any other rule? A new thing here? All the basic rules.
No, doctor.
KCL, KVL, Kirchhoff current, divider, voltage divider, current divider, Ohm's law, everything will be same. So these formulas which we use here must be on your tips. Like that, quickly, you will say, yeah, this one. Then only you will enjoy. Yes. So we have done with this. Let's move to another point, or let's maybe another question. So what is that one? See, answer is here, by the way. Earlier you say, okay, guys, answer is I for 3.45. You can apply anything and you can get it. So this is the, and every mashallah, you got all 3-4 ways we tried, we get the same answer. Good. See, so it's again a similar question. Provided bus, one resistance is missing, which was there. See this one, yani R1 is not there this time. Voltage is now 10 volts. Okay, so let's try to just calculate all current, all voltage here, not I4 only. So R1, R2, R3 is given. I can calculate R total. How can I calculate R total? Because it is a combination circuit. So R2, R3 is in combination. So I will apply combinational concept. Then this combination will be in series with R1. So this way I can get the R total. Okay. So R total is coming 464 ohm. Okay. You can do this one, but I am explaining now. Now, second thing comes, I will calculate the currents. So once I have RT, which current I can calculate, girls, after knowing RT? Can I calculate IT easily? So I will go for IT. IT formula will be VS over RT, 10 over this one. Correct?
Yes.
So I will be getting this current. All right. Now, I want to calculate I1. Can you tell me what will be the I1? Any current through R1?
Equals
We
21.
must find.
Same as IT.
Same as IT. Absolutely right. It's so simple because total current is flowing this way and first it will go to R1. Yani same current will be there. So I can say I1 will be same as IT. All right. Now after that, what I can do, I need to find V1, V2, V3. So can I find now V1? Because I know I1 and R1. So I can apply
Yes,
Ohm.
we can.
Yes, we can.
Yes, so this is something. 5.82 volts. Now, so here, now either you can go for I2 or you can go this one. Yeah, it's up to you now, guys. Yani, you can see here, this I total is coming here. This is IT, and it is dividing into two parts. Again, you can see this is the node, and here is the split up of the current. This is I2, and this is I3. Okay, so I will apply here current divider. So by applying current divider, you can calculate I2 and I3, correct?
Yes.
Okay, so you can calculate the currents. Also you can calculate V2 and V3 if you want. Yani, this is okay. I2 and I3 calculate first, then we can calculate I2 and I3. Okay, what I am saying, you can directly calculate this one, you know, this one. Yes, how you are calculating this one? 10 minus 5.82. See, yeah, this is the way. Yeah, we can go for this way. If we know how much voltage drop is there, you know, if we know this one, and which is given, actually we already calculated, which is 5.82. So it means, where is the remaining voltage? So remaining voltage between this and this, it will be dropping here. This is something. Okay, so it is so simple. I can apply here KVL, Kirchhoff Voltage Law. It says that, what it says? It says Vs is equal to V1 plus V2 or V3, whatever, because they are in parallel. So here I can calculate simply V2, which is equal to V3, is equal to 10 minus 5.82. Yes, Mariam. So correct. This way we can also calculate these V's. So this is the way to calculate the V1, V2 and V3. Once I get V1 and V2 and V3, I can calculate the currents. Simply, current will be different because it is a parallel circuit. Any R2 and R3 connected in parallel. So this is the way. Now we can calculate P1, P2, P3. We know that one. Just simply formula we can apply and we can calculate, yeah, P is equal to I into V, and we can apply this one here. See this one? It's so simple. We can simply calculate this way.
Doctor?
Yes.
I have a question. When we put milliwatt and when we put watt, only watt,
Okay.
and same milliampere and ampere, يعني كذا.
Okay. So here it's
we can define.
Just put the values. You know the formula, P is equal to V into I. You are not putting anything from your side. You need to get it from the unit. What is the unit of V1 here? If you are, for example, calculating P1, so it is V1, I1. Okay, this is something. So when you are calculating, tell me what is the unit of V1?
V1 unit,
yeah.
V.
Volts.
Voltage.
Volt.
Yeah.
Okay. And what is the unit of current?
Ampere.
Ampere. Look it again. What is the current unit which is given to you? I1 unit.
Milliampere.
Milliampere. Okay. So here, do you know that ampere multiplied by volts, what it will give me?
R.
No,
sorry. Watt.
Watt, because I'm just looking for the units. And what is remaining now? Milli. Bas khalas.
Yeah.
Bas.
Thank you, Doctor. I understand it.
Okay, the same way it will work for all. Yani this time I am just telling you the units. So this is the way. So in this way, you need to just multiply 21.6 with 5.28. You just multiply. You are getting this answer. And unit is the same which I just explained. Volt multiplied by milliamps. Amps and volts will become what? And milli is there because it is in product simply. That is the way. Okay, so this is the summary of this one. Okay, now see, do you know one more thing now, which is about the KVL, Kirchhoff Voltage Law. Kirchhoff Voltage Law can be applied to any closed path. Yani, I can apply KVL this way. Look, this is a closed path. I can apply this way. Another line, I can also apply KVL this, and this. Both ways are possible. Closed loop. This is closed loop. So if you want to apply, so you this is what 10, and you know that if I am considering this is the direction of current flow, so I always told you this is negative, this is positive, this is positive, this is negative. All right, this is positive, this is negative. Now which one you want to apply? Let's suppose you want to apply for the blue one. So if you apply blue one, so you will be writing like -10. I am applying that all algebraic sum of all the voltage drop is equal to what I'm trying to say, 0. Okay, then plus I am writing V1, and another one is for the blue one, for the red one, let's suppose this is V3. So from here, can I say now V3 is equal to 10 will go on 10 will go another side minus V1, and V1 we already calculated. How much it is the V1? 5.82, and it is giving me 4.18 volts. This is the red one. Okay, red KVL, yani inner outer loop. See the inner loop now. If I apply to the inner loop, which will also work. Okay, just a minute, just make it red. Now I will rewrite for the blue one, yani inner loop. So for the inner loop, again -10 plus V1 plus V2 is equal to 0 KVL. So I can also say V2 is equal to 10 minus V1, which will be 4.18 volts. So this is what KVL. KVL can be applied to any closed path, Okay, so are you thinking, can we apply to one more closed path? Which one? Can we apply here as well? Because it's also a closed path. Just let me take another color. Yes, all right. Okay, so let's apply here. If I apply here, okay, I'm writing here. So just start from the direction. So what is that? Minus V2, then plus V3 is equal to 0, correct?
Yes.
Now, can I say V2 is equal to V3?
Yes, I can.
Okay, so now, is this true or not?
Yes, this is true.
True also. You can check here. V1, V2 and V3 is also equal. So it's true. So this is the beauty of KVL. You can apply to any closed loop. And this is the way. But provided the direction or current, need to understand this way. So we get it. So you can apply to anywhere in order to understand it. So this is the basics of KVL. All right, guys. So we have done here. Just remove this. And what next is there? When you have lecture tomorrow, I believe, right?
Yes.
Yeah, PT. Just a minute. What is that? PT is the always the sum of the P1. Yeah, Fatima, it is always sum. You have a lecture tomorrow, correct?
Yeah,
right.
Doctor. At
Okay.
3.
So for now, it's okay, or should I continue this also one more topic? This one. This is 2 slides. I believe was 2 slides. Okay. Just cover these 2 slides. I must give me 5 more minutes, or what do you want? If you want, okay, then I will leave. Otherwise, I will take more 5 minutes and I will stop here. 2 slides.
Doctor,
Yeah.
I have a question.
Yes, Shahan.
دكتور الحين voltage divider, okay? We must find the largest output and the smallest, right? The
Again,
small,
Again, what's that? Smallest and?
Yeah, the largest output voltage with the smallest output voltage, right?
Okay.
The larger, the smallest, it's always be 0.
No. It will not always be 0. It depends. It depends. Maybe you are referring some question which is in your mind. Do you have that question with you? It depend upon the figure.
Because the slide it says 0, so how we can define
which slide you are talking? Which slide you are talking?
Slide in chapter 4.
Chapter 4.
15.
Rana is in your group, Rana? No.
15.
This one?
Yes.
So here it is, see, here is, it's about that, the position of the arrow. When this arrow reach here, I told you, when this arrow reach here, what is in between this point and the ground? How much is the resistance now?
It will be 0 because we don't have a resistor here.
Correct. It's 0. So when resistance is 0, voltage will be 0 or not?
Voltage will be 0.
Okay, this is something. Now, see the scenario, this different case.
Yeah.
Here I am taking output, these 2 points. So this is, let's suppose R1, this is R2, this is R3. Let's consider the values. So let's say the value is 10 ohm, 2 ohm, 12 and 3 ohm, and this is a complete circuit now. And here I am having 15 volt source now. So I'm asking you, minimum voltage and maximum voltage, V out. So how you will be solving this one now?
Can I write?
Yeah, you can write, yeah. But if you tell me, I can also write. You just tell me what you want. I will write it. Maybe it will be more clear. That's why.
Okay. دكتور يعني we will do same the row green row up.
Okay. So you are looking for minimum. So
Yes.
minimum, yeah, for the minimum it could be here. Correct? Yani just down. Correct?
Yes.
Okay. If it is here, what is in between this point and the ground? How much is the resistance between these 2 points?
3 ohm.
3 ohm. Correct. So I can say V out. And what is that one?
Minimum.
Minimum.
Yeah.
So I will write here voltage divider, which is 3 over the sum of all resistances. How much?
15.
15 multiplied by 15. Answer is 3 volt. Clear?
Yes, clear.
Okay. Now I am using different color to show you. Okay, which color? Pink, girl's favorite color. Okay, so here, this is the point now, maximum, right now. So this is the maximum position. So what do you think from here to ground now? How much is the resistance? 13. All right. So V out max. So 13 over total resistance, yani 15, correct? Multiply 15. So 15 will cancel 13. Do you have zero this
clear. No, we don't.
Bas?
Yeah, clear. Thank you, Doctor.
Welcome. Okay, so that's now time finish. All right, so we'll continue inshallah tomorrow with this one, and before that you must revise. That will be good, and we'll continue inshallah. Any question if you have, you can ask. I am done. I will take this attendance quickly. I'll check. You are 33. Just let me just double check. So your group number 3, group 3. Okay, so today is 9th. All 33. Okay, you all are present. Khalas. Finish, girls. Okay, so inshallah tomorrow